First step is I want to recount what we did over here. What we're doing over here was we were guessing and checking. We're trying to figure out -2, plugging it in, 0, plugging it in, 2, plugging it in, and then trying to see where the pattern's going. And sure, with enough experience, I can get that pattern. It's just not going to happen all the time for you. Your guessing and checking is a real bad way to try to graph, I think. So I'm going to teach you a little bit of calculus. This is called the chain? No, not chain rule. A power rule. So the power rule uses powers. Uses the exponent, right? To be able to do things. I'm going to show you this power rule real quickly. Right, Sean? Real quickly so that you guys can learn this. Because this calculus, you're not far from this. Okay? Alright, so here it is. The first step is we're going to find the first derivative. Okay? We're going to find the first derivative and set the first derivative equal to 0. That's going to get us our axis of symmetry. Okay? The second step is going to be, we're going to take that axis, we're going to plug it into the function. Okay? You're going to plug it into the function, and that's going to give us the vertex. From there, we're going to find two symmetrical points. Real easy symmetrical points. The easiest thing to use is 0. Okay? And then, if I use 0, then I can always use 2 times the axis, and that's going to actually give me another symmetrical point away, depending on which way away from 0. Right? And it always will be symmetrical. And so those 2 easy points. And the second one will be a check because it should equal whatever the f of 0 is. And f of 0 is always the last number. You plug in 0 for x, it's 0, 0. Everything goes to 0 except for the last number, right? So that's why that one's really easy. Okay? So follow me through this and it'll be easy. If you don't follow, it will get confusing quickly. Alright. Here we go. The first derivative is using the power rule. Is I'm going to take this power and I'm going to multiply it by the coefficient. Okay? Take the exponent times the coefficient. Okay? And what I call this is the first derivative. We're deriving it from here. Okay? Now, 2 times 2 is 4. And then what I do is I subtract 1 from the exponent. And that gives me a nice 1. So it's just 4x to the 1. Okay? Now I take this 1 and I multiply it times 4. And I get 4, right? But when I take 1 away from 1, what do I get? None. So I get x to the 0, which is just 1. So I don't even need it here. In fact, I have an x to the 0 here, but when I take the 0 times the 1, it goes to 0, everything goes to 0, so I'm done. It's just basically these 2 things. So when you're dealing with quadratics, it's really easy. You take the 2 times the coefficient, and then you bring down the number, and you're done. It's that simple. Okay? Now, I'm going to set this equal to 0. Alright? I want it equal to 0 because the thing I'm doing here is I'm finding slopes. Okay? What derivatives are is we're looking at the change in the function. So the instantaneous change is really the slope of the function at that point. So the most important slope that I'm worried about is the slope that's 0. Because when we got something like this, that's a 0 slope, is going to find me that point. And when I have something like this, at 0 slope, it's going to find me that point, right? So that's why the 0 is so important. That's why we're plugging in 0, okay? We'll learn more about that later. But the cool part is just plug in equal to 0 and solve. So now it's just basic algebra, right? Minus 4, 4x equals -4, okay? So now I divide by 4, and I get x is equal to -1. Okay? That is my axis of symmetry. Okay? From there, I go to my second step. I plug in the axis of symmetry. I find f of -1. Well, that equals 2 times x squared plus 4 times x minus 1. Well, in this case, x is -1. So I'm just going to plug in -1 and -1. If I do the math, I've got -1 times -1 is 1. 1 times 2 is 2. -1 times 4 is -4 minus 1. Okay? So now I've got 2 minus 4 is minus 2 minus 1, which is minus 3. Okay? So f of -1 is equal to -3. This gives me my vertex. The vertex is -1, -3. Okay? So if I want to graph it, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. -1, -3 is -1, -3. Okay? And so that's my vertex. Okay? This is my axis of sim. Okay? Okay, so that's that purple right here. This is the axis of sim. Okay? So I have my vertex, I have my axis of sim. Okay? And now I just want to get a couple of good points. Just a couple of good points. And we said, hey, the easiest point I could grab is at 0, right? If I plug in f of 0, then I have 2 times x squared plus 4 times x minus 1, right? Now I'm going to plug in 0, 0, and 0. Well, these go away. So f of 0 is just -1. That's the easiest thing I can think of. So that's the point 0, -1. That's why we write this in the f of x form. Okay? So now I've got 0, -1. Okay? Now, I want to do my check method. F of 2 times the axis. In this case, how much is the axis? -1. So how much is 2 times -1? So I'm plugging in -2. And I'm plugging it into 2 times x squared plus 4 times x minus 1. I'm just going to plug in -2, -2, -2. -2 squared is 4. 4 times 2 is 8. -2 times 4 is -8. Plus, or minus 1. 8 plus -8 is 0. So f of -2 equals -1. So I'm going to plug in -2, -1. Right? And from there, -2, -1, Wyatt's parents and John's parents will be able to hear them talking and know that they weren't paying attention. So that's why they did poorly on the test. So now I've got these in, and I just graph it. Right there, right there. And that's what we're going to be doing. We're graphing these quadratics. And last week we were finding, the parent functions, right? We knew what the quadratic looked like, but we couldn't graph it yet. We know what this quadratic looks like, and now we know how to graph it. Okay? So that's the first step for that.